It's something we probably never think about. We trust that the tools used in a hospital or a lab are completely safe. But how can we be absolutely 100% sure? Well, today we're diving into the intense world of proof, the high-stakes quest to verify. It's something we probably never think about. We trust that the tools used in a hospital or a lab are completely safe. But how can we be absolutely 100% sure? Well, today we're diving into the intense world of proof, the high-stakes quest to verify that a machine designed to kill every last germ works perfectly. Every single time.
Really think about that. When it comes to a surgical instrument or medicine you're going to inject, mostly sterile or probably sterile, that just doesn't cut it, right? You need absolute certainty. So how do you get there? How do you prove that not a single living microorganism is left? That's the huge question we're going to tackle.
So let's meet our main character, the autoclave. Honestly, the easiest way to think of it is like a super-powered pressure cooker. It uses this incredibly hot, high-pressure steam to just obliterate any and all microbial life. It is the absolute cornerstone of safety in medicine, in labs, and manufacturing. But just having one? Oh, that's not nearly enough.
And right here, this is the crucial point. The real challenge isn't just doing the sterilization. It's about creating a rock-solid, documented, verifiable process that proves it happened correctly. That whole process, it's called validation, and it's basically a journey of intense scrutiny.
Okay, so how does an autoclave even earn its stripes? Well, it has to run what I like to call a three-part gauntlet. It's this series of demanding trials designed to test every single aspect of its performance before it's ever cleared for duty. These trials are officially known as qualifications, and they have to happen in this specific order. First up is installation qualification, or IQ. Then you have operational qualification, OQ, and finally, the big one, performance qualification, or PQ. It's this really logical progression, from checking the setup all the way to proving it works in the real world.
Okay, so let's break this down. First, with IQ, you're just asking a simple question. Is this thing installed correctly? We're checking that it matches the manufacturer's specs, that the power and water are hooked up right, all the basics. Then we move to OQ. Now the question is, does it run correctly when it's empty? This is where we test all the controls, the alarms, and we do this critical thing called temperature mapping to make sure heat is getting everywhere evenly. And then finally, we get to PQ. This is the real test. Does it actually sterilize things when it's full? This is where the rubber meets the road.
And inside that final PQ phase, that's where the ultimate test is waiting. See, it's not enough to just sterilize normal stuff. To really truly validate this machine, you have to prove it can defeat the toughest opponent imaginable. It's kind of like the final boss battle. It's time for the autoclave to confront a superbug. And here it is, our superbug, Geobacillus asterothermophilus. Yeah, don't worry about pronouncing it. All you need to know is that its spores are some of the most heat-resistant little things on planet Earth. The logic is simple. If you can prove your autoclave kills this, you can be totally confident it's going to kill anything else. So how do they do it? They use something called a biological indicator. Basically, they stick tiny vials full of these superspores right into the autoclave's load. And they do not make it easy. No, they strategically hide them in the absolute hardest places for steam to reach, like deep inside a dense pack of surgical tools or in whatever spot in the chamber has been identified as the coolest. The whole goal is to create a worst-case scenario. And here's how you get the verdict. After the cycle is done, they take those vials and incubate them. If nothing grows, it means every last one of those ridiculously tough spores was destroyed. It's that simple. The total absence of life is the definitive proof that the process worked. It's completely all or nothing. So, once the autoclave has run the gauntlet and defeated the superbug, you'd think the journey's over, right? Not quite. Now comes the final and maybe the most important step, turning all those test results into a formal verdict of certified safety. The absolute golden rule of validation is document everything. Every protocol, every single test result, every calibration certificate. It all gets recorded. This creates a complete, traceable paper trail that can be checked during an audit. Because in the world of validation, if it isn't written down, it might as well have never happened. And it's so important to get this. Validation is not a one-and-done deal. You have that initial, super comprehensive validation before the machine is ever put into service. But then you have routine revalidation. That means you're periodically retesting to make sure nothing has changed, that the machine is still performing perfectly year after year. It's an ongoing commitment to safety. Now, this whole process isn't just a good idea someone had. Oh no. It is a strict requirement. It's guided by international standards like ISO 17665 and something called Good Manufacturing Practices, or GMP. These regulations make sure that every single organization performs these critical safety checks to the exact same high standard, no matter where they are in the world. So let's bring it all home. What's the one thing you should really take away from all this? It's that validation is the bridge that takes you from just hoping something is safe to knowing it is. It transforms a simple assumption of sterility into documented, verifiable, undeniable proof of safety. So, we've just walked through the incredible journey to prove that just one type of machine is safe. It really makes you wonder, doesn't it? What other invisible, super rigorous processes are happening all around us every single day just to guarantee our safety? That's something to think about.